Guys, we're going to start today by following up just a tiny bit on the population and parameter and sample and statistics. So remember we said the population is the whole group and a sample is just part of the group. So for example, a parameter would be like the SAT scores for all students at JHS, right? A sample would be SAT scores for all 10th graders at JHS, right? So I would only take some of the population, not the whole thing. So population is the whole group. It's the parameter. Remember, population and parameter both start with P, and sample and statistic both start with S. So any numbers that go with the sample is a statistic, and any numbers that go with the population is a parameter. So you did these examples already. I'm just going to go over the correct answers. So Jorge surveys each of the teachers at his school. There are 128 total teachers at his school. He concludes that 64% of the teachers in his school enjoy reading as a hobby. So he surveyed each of the teachers in his school. That means all of them. So that is the population. And so the 64% is a parameter. A car dealer wants to know which of the 5 new car colors the customer prefers. He asks every 5th person who enters. During March, 33% choose red. So every 5th person, that is a sample, which means that 33% is a statistic. All right, and then after examining 8 cartons of eggs at a local supermarket, all right, 8 cartons of eggs is just part of the eggs. She concludes that 1 out of every 12 eggs packaged in the U.S. is cracked. So she surveyed 8 cartons, so that would be a sample. So 1 out of every 12, that's going to be your statistic. Did I spelled statistic right? Yep, okay, statistic, because it has to do with the sample. All right, so let's move on to something a little newer. So this is what we're going to use for predicting outcomes. So you had a couple questions about this in your other notes, and you probably were not able to answer them completely. So predicting outcomes is using the population and statistic or sample numbers to predict what's going to happen next. So members of the marching band plan to sell cookie dough to raise money for new uniforms. They survey 60 students at random to determine their favorite type of cookie. The results are shown in the table below. So they order 500 tubs of cookie dough. How many tubs of sugar cookie dough should they order? So what you're going to want to do here is you're going to want to get a total for the sample. Okay, so this is your sample that they have right here. And so you're going to want to add these numbers up. So you have 17, 18, 19, 20. So 2, 4, 5, 6. So you have 60 total, which is good because that's what they said was going to be your sample. So out of the 60, 18 of them are going to be sugar cookies. So you're going to do 18 out of 60 equals, and they're going to order 500 tubs total. So you want to know how many out of 500. So we're just going to do the cross multiplication thing again and solve for x. So if I get 60x equals whatever 500 times 18 is, I get 9,000. And then I'm going to divide both sides by 60. And I'm going to get 150. So I'm going to order 150 tubs of sugar cookies. So the 60 is an example of a statistic or a parameter. So 60 had to do with the sample. So 60 is a statistic. 500 had to do with the total that they were ordering. So that is the parameter. All right, I'll do another one. So there are 450 total students in 8th grade. How many would you expect to send at least 76 text messages a day? So 76 or more is 32. But we need to get a total. Probably we should have read the whole problem. 75 random 8th grade students were surveyed to see how many text messages they send each day. The results are shown in the table below. So 7, 8, 9, 10, 11. So just to make sure our numbers add up, 3, 4, 5, 6, 7. Yep. So 32 out of 75 is the number here. And then if we have 450 total, how many would that leave us? So we're going to do 75x, and then 32 times 450 is 14,400 text messages. And we'll divide that by 75. And so we'll get 192 8th graders. All right, that's how many we would expect to send at least 76 text messages a day. All right, so again, these numbers are our statistics. So both of these, if it asked about either one. And then this, the 450 and the 192, those are going to be parameters. Okay. All right. A group of middle school students were randomly chosen and asked about whether they are going to attend the school carnival. Of those, 65% said yes. If 52 students responded yes, how many students were surveyed? Okay, so this is a little bit different. So if I know 65% said yes, and that is 52, that means we're going to go back to 9th grade again and say 65% of some number is 52 students. All right, I can turn that into a decimal. If I do 65 times some number is 52, then I can just divide both sides by 0.65. And x is going to give me 52 divided by 0.65. And that is going to give me 80 students. There we go. If there are 1,600 students in the school, predict the number of students who will attend the carnival. Well, they said 65% said yes, so I could just do 65% times 1,600, or 0.65 times 1,600. And that is 1,040. And then is 52 an example of a parameter or a statistic? So 52 was the part. So 52 is a statistic. 1,600 was the whole population. So that was the parameter. That's an E. Alrighty, and that's all there is to that. So if you have any questions, just let me know.